Hi there, this is Weblan. We are continuing with our introductory trigonometry. Alright, I have two triangles here and I want us to look at how to determine the lengths of sides of a right angle triangle using the three trigonometric ratios that we have looked at earlier on. Now in these triangles, I want us to determine the size of x and the size of y in that first triangle. We have angle 30 here, 30 degrees given, and x is opposite, and y is adjacent, and 2 is hypotenuse. So, if we are looking for x, we are given 30 degrees and we are given the hypotenuse, that's 2 units. Now you make use of what you are given. In this case, you make use of the angle 30 degrees and the hypotenuse 2 units. Now, to get x, you need to ask yourself this question. There is the angle, we have the opposite, and we have the hypotenuse. Of the three trig ratios that we have looked at, which one do you have which has both the opposite and the hypotenuse? That is sine theta. So you use sine 30 degrees here is going to be equal to opposite over hypotenuse, and our opposite is x. Our opposite is x, so this is x over hypotenuse is 2. So to get x, you need to take 2 to the other side. We do that by multiplying both sides by 2. So we are going to get that x is equal to 2 multiplied by sine 30. 2 multiplied by sine 30. Now, on our calculator, we have our trig ratios here. Here is sine, here is cos, and here is tan. Now, to get the value of x here, it's 2 multiplied by sine 30 degrees. And this one is equal to 1. So, x is 1 unit. And then the second one, we have y. Now, to determine y, we make use of what is given. We have a 2 and we have an angle theta, angle 30 degrees. Y is adjacent to 30 degrees. So, which trig ratio do we have which has adjacent and hypotenuse? That is cos. So this is cos theta is equal to adjacent over hypotenuse, right? So we have cos 30 is equal to y over 2. Y over 2, and we take our 2 to the other side. We are going to have that y is equal to 2 multiplied by cos 30. 2 multiplied by cos 30. This is going to be equal to what? 2 multiplied by cos 30. This is equal to the root of 3. I'm leaving it in said form. So our x is equal to 1 and our y is equal to root of 3. Let's look at the second question. You can pause video and do the question, then you look at it after answering the question yourself. All right, we are looking at our triangle, right angle to triangle, and on this triangle we have the angle given 22 degrees, you are supposed to determine N and determine M, and you are given the opposite. 14 is the opposite side to the angle 22 degrees. Now, which one should we start with? Let's start with N. Let's start with N. N is the hypotenuse of this triangle, so we want the ratio which includes opposite and hypotenuse, that is sine. So in this case, we are going to write sine 22 degrees is equal to, our opposite is 14 units, divided by N. Now, we want this N. How do we do that? I believe you have already looked at how to solve basic equations. So the first step is to multiply both sides by N. You are going to have N multiplied by sine 22 is equal to 14, and then you divide both sides by sine 22. Then you are going to have N is equal to 14 divided by sine 22, and this is going to be equal to what? On your calculator, it's 14 divided by sine 22, and this is equal to 37,37. Remember, it's not 37,37, but it's 37,37 units. And then the second one, determining M. M is adjacent to 22 degrees. So we want a ratio that includes adjacent and opposite. Which ratio is that? That's 10. So it's 10, 22 is equal to opposite over adjacent. Remember, SOHCAHTOA, tan theta or tan 22 is equal to, opposite is 14 over adjacent, it's M. So our M here will be equal to what? Our M will be equal to 14 divided by 10, 22, which is equal to 14 divided by 10, 22. On your calculator, this is going to be equal to 34,65 units. 34,65 units. With this one, we were looking at how to determine the sides of a right-angled triangle given a side and an angle. Now let's look at how to determine the angles on a triangle, making use of these ratios. Okay, we need to calculate angles this time. We need to calculate angles. Before we calculate angles, let me show you something. Okay, we agreed in the previous section that you can determine the ratio of something like this. Sine 30. On your calculator, sine 30 is equal to 1 over 2, or is equal to 0,5, right? How about the reverse or the opposite of this procedure? You were given the angle and the trig ratio of that angle is equal to 1 over 2. Now, if you are given the ratio itself, and you are asked to determine the angle. It is a matter of doing the opposite, and we call it the inverse procedure. This is going to be the inverse of sine 1 over 2. It gives you what? On your calculator, this is the first function of sine. On top of that sine, we are given sine with a power of -1 there. That is the inverse. So to get that second function, it's a matter of saying shift and then you press your sine. You see it comes with that -1. So 1 over 2. So the reverse procedure is inverse of sine 1 over 2. That's equal to 30 degrees. So if you are given the angle you want, the ratio, it's a matter of saying sine 30, you get your 1 over 2. If you are given the ratio, you want the angle, you do the inverse procedure. That's inverse of sine 1 over 2. It gives you 30. Now let's look at how to determine angle. All right, the first triangle is a right angle triangle. We are given angle theta, and then we have a side opposite angle theta and a side adjacent to angle theta. We want to use these two sides to determine our angle. We agreed that if we have opposite and adjacent, which trig ratio is that? It's tan theta. Tan theta is equal to opposite over adjacent. That is 10 over 15. Now, how do we get theta from what we have? We are supposed to do the inverse procedure. That is shift 10 over 15. This is equal to what? This is equal to what? Some calculators you have a shift, but other calculators you have a second function. So this is shift 10 over 15. That's equal to 33.69 units, rounded off to the nearest 2 decimal places. And then the second triangle, we have angle theta, then opposite is 3 units, hypotenuse 5, adjacent is 4 units. Now how do we get theta? I want us to get theta making use of tan, using cos, and using sine. The first one, sine theta is equal to opposite over hypotenuse. That is 3 over 5. 3 over 5. Sine theta is opposite over hypotenuse. So using sine, our theta is equal to the inverse of sine 3 over 5. This is equal to what? On your calculator, second function, sine 3 over 5 is equal to 36.87, rounded off to the nearest 2 decimal places. We could also use cos. So if we say cos theta is equal to, cos theta is adjacent over hypotenuse, right? So this is adjacent divided by the hypotenuse, that is 4 over 5. That's 4 over 5. So our theta here will be equal to second function of cos 4/5, and this is going to be equal to, on your calculator, second function or shift cos 4/5. That's equal to the same answer, 36.87 units to the nearest 2 decimal places. And we can also use 10. So using 10 is tan theta is equal to, tan is equal to opposite over adjacent. That's our opposite is 3 over adjacent is 4. So this is 3/4. And our theta then is equal to the second function or the inverse of 3/4. The inverse of 3/4, it gives us what? The inverse of tan 3/4. That gives us 36.87, rounded off to the nearest 2 decimal places. So you can see that on our triangle where our opposite is 3, adjacent is 4, and hypotenuse is 5, we used sine. So the second function of sine 3/5, it gave us 36.87. The second one using cos theta is 4/5, and the second function of cos is 4/5, it gave us 36.87. And then the last one, we made use of 10. Tan theta is opposite over adjacent. Our opposite is 3, adjacent is 4. We got the same angle once again. Let's look at the last question. All right. We've got a combination of 2 triangles here, and we want to determine the size of angle alpha and the size of angle beta. If you had never met these 2 letters before, these are letters borrowed from the Greek alphabet, which we use to denote angles. Previously there we made use of theta. We also have alpha and we have beta. We normally use these letters when we discuss angles. So let's look at alpha. To get alpha, we have the side opposite and the adjacent side. Which trig ratio do we have which includes opposite and adjacent? Do you remember SOHCAHTOA? Our SOHCAHTOA, the last one is TOA. That's TOA. That's tan is equal to opposite over adjacent. So tan alpha here is equal to opposite, that's 78 units, over adjacent, that's 82. So our alpha then is equal to the inverse of tan 78 over 82. This is equal to what? Go to second function, tan 78 divide by 82 in that bracket. Okay, bracket should cover both of these. That's equal to 43.57 units to the nearest two decimal places, that is alpha. Now we want beta. Remember, to determine an angle you need two sides. To determine a side you need an angle and another side. Now in this case we only have this side. We need another side. How do we get another side? We make use of this triangle. We can determine the hypotenuse of this triangle. How would we do that? Let this be equal to, I'm going to call this small n, letter n. So my n squared, let me write it here. N squared is equal to 78 squared plus 82 squared. That is according to Pythagoras theorem. So our n will be equal to the square root of 78 squared plus 82 squared. And using our calculator there, we want the square root of 78 squared plus 82 squared. This is equal to 113.17243. Remember, this is not my final answer, so I cannot round off an answer before I get to the final answer. We'll have to use it with these 5 decimal places. Now we have this side and this side, which we named n. That's going to be what? We want alpha, we want beta, and we have hypotenuse and adjacent. The ratio which has hypotenuse and adjacent is what? Remember, so, ka, to. Ka is adjacent over hypotenuse. So this is going to be cos beta is equal to adjacent, that is 113.17243 all over, it continues all over hypotenuse, that's 134. So our beta then, beta is equal to the second function of 113.17243 all over 134. This is equal to, on your calculator, shift cos 113.17243 all over 134. Close the bracket, and we have that's 32.37 units. So our alpha, we saw that is 43.57 degrees, and our beta is 32.37 units. So you see, when you are determining angles, you make use of two sides and the ratio. That continue practicing. Remember, practice makes perfect. Enjoy.